Right now, satellites above your head are aging faster than you, not by much, microseconds. But it's real. Here's something stranger. Your head is aging faster than your feet, microseconds, but measurable, proven, happening right now. Most people think time is universal, one giant clock, ticking the same everywhere. That belief is not a little wrong, it's fundamentally wrong. Time doesn't flow, it bends, stretches, compresses, and the thing bending it, gravity. Gravity literally changes how much duration exists in a region of space. Sit in your basement, you age slower than your neighbor on the top floor. The universe keeps strict books, and the currency isn't money. It's time itself. Let me show you. Look at your wrist. Imagine a watch there. Simple thing. It ticks. Counts seconds. You trust it. Now imagine this. Two identical watches. Perfect twins. Same factory. I synchronize them to the nanosecond. One goes to Mount Everest. One stays at sea level. I wait 1 year. Bring them together. Here's the part nobody tells you. They don't match anymore. The mountain watches ahead. Ticked more times. Experienced more duration. Not broken, not temperature, not air pressure. Because time itself moved faster up there. Wait, time itself moved faster. This isn't theory. 1971. Two physicists flew atomic clocks around the world on commercial jets. The clocks disagreed when they landed, exactly as Einstein predicted decades earlier. Your wristwatch isn't measuring universal time. It's measuring local time, right where you're standing. And where you stand changes everything. Your feet are closer to Earth's center, deeper in gravity's grip. There, time runs slower. Your brain lies to you. It feels like time is constant, universal. That's the lie evolution built. But for physics, those differences are everything. Why does gravity care about time? Hold that thought. Here's what school taught you. Mass pulls mass. Newton's apple. Simple, that's not wrong. But it's a description, not an explanation, and here's where your intuition fails. Gravity is not a force pulling on things. Gravity is the shape of space-time itself. Let me say that again. Gravity is shape. Imagine a bedsheet stretched tight. Drop a bowling ball in the center. The sheet bends, curves, creates a dip. Roll a marble across it. Does it go straight? No. It curves toward the bowling ball, not because of pulling, because the sheet is bent. Exactly. That's gravity. Space and time aren't separate. They're woven together. Space-time. And mass bends that fabric. Earth doesn't pull you down. Earth bends space-time around it. You're following that bend. But the sheet isn't just space. It's space and time woven together. When mass bends space-time, it curves your path through time. And here's where it gets even stranger. Near massive objects, space-time is more curved, more compressed. In that compression, time itself runs slower, not clocks. Duration itself, reduced. Think of walking through a field, flat ground. Each step covers the same distance. Now the field tilts into a steep hill. Each step is harder, covers less ground. Space-time near mass is like that steep hill. But for time, your basement is deeper in Earth's gravity well, less duration per moment. Your roof is higher, more duration per moment. Reality doesn't issue refunds. Now here's the enforcer. Light. Light always travels at the same speed. Always. No exceptions. 300 million meters per second. Locked. Now watch what this implies. Speed equals distance divided by time if light's speed is locked. And distance changes because space-time is curved. What has to change? Time. Time must bend, must stretch, must compress, because light's speed cannot change. The constant is enforced. Light doesn't negotiate. Light sets the terms. Space-time obeys. This is why gravity makes clocks run slow, not because gravity interferes with mechanisms, because there is literally less time happening in stronger gravity. The universe keeps brutal books. The accounting is perfect. More mass, more curvature, less duration. Simple and inescapable. Bern, Switzerland. A 28-year-old patent clerk sits at his desk. He's already changed physics once. Special relativity. Proved time slows when you move fast. But something bothers him. His theory only works for constant motion. What about gravity? Then it hits him. He later called it the happiest thought of his life. Einstein imagined a man in an elevator. Cable snaps. Elevator plummets. What does the man feel? Nothing. Weightless. If he drops his keys, they don't fall. They float beside him. Everything falls together. Inside that box, gravity has vanished. Wait, now Einstein flips it. Same elevator. Deep space. No gravity anywhere. Rocket engine fires beneath it. Accelerates upward. What does the man feel? Pressed to the floor. Wait. His keys fall when dropped. Inside that box it feels exactly like gravity. Exactly. The man cannot tell the difference. No experiment can distinguish between standing on Earth and accelerating through empty space. Einstein made it law, the equivalence principle. Gravity and acceleration are the same thing. This isn't preference, it's accounting. Now here's the brutal implication. Special relativity says acceleration affects time. If acceleration and gravity are equivalent, gravity must affect time too. Must. The logic is airtight. Einstein saw this in 1907, 8 years before finishing the math. Newton gave us absolute time, universal clock, God's metronome. Einstein shattered it. Time is local, personal, dependent on where you stand. Your time is not my time. Your lifetime is not my lifetime. But thinking isn't proving. The proof starts with a beam of light bouncing between two mirrors. Forget complicated clocks. I'll build you the simplest clock possible. Two mirrors facing each other, one photon bouncing between them. Photon goes up, hits mirror, bounces down, hits mirror. Each bounce is one tick. This is called a light clock, the purest way to measure time. Why? Because light's speed is constant, locked. The time between ticks is perfectly predictable. Now watch what this implies. Put this clock in weak gravity, far from any planet. Photon bounces straight up and down, short path, fast ticks. Now move it to Earth's surface, more curved space-time. Here's where your intuition fails. The mirrors haven't changed, the photon hasn't changed, but space itself is curved. The path between mirrors is longer, geometrically longer. The photon can't speed up. Light's speed is locked, so the ticks take longer. The clock runs slower. The clock isn't broken. It's measuring time perfectly. There's just less time happening. Done. Do this right now. Hold your hand flat. Raise it above your head slowly. Your palm moved through space-time curvature. At waist level, more curved, time slower. At head level, flatter, time faster. Your hand aged faster during that motion. Wild. Scientists raised an atomic clock 33 centimeters, 1 foot. The higher clock ran faster. Measured. Published. 2010. 1 foot of height. Detectable time difference. The universe keeps meticulous books. But what about technology you use every day? What about your phone? Your phone knows where you are. Within meters. Simple. Wrong. Behind that blue dot is the most precise timekeeping system ever built. It only works because Einstein was right. Here's how GPS works. 31 satellites orbit Earth, 20,000 kilometers up. Each carries an atomic clock. They broadcast timestamps. Your phone receives signals from 4 satellites, compares them, calculates distances, 4 spheres. Your location is where they intersect. Beautiful math. But here's the part nobody tells you. Those satellites are wrong. Their clocks tick at the wrong speed. 2 effects happen. First, satellites move fast. Special relativity says moving clocks run slow. They lose 7 microseconds per day. Second, satellites are high up. Weaker gravity. General relativity says clocks in weaker gravity run fast. They gain 45 microseconds per day. Net result, 38 microseconds faster daily. Sounds tiny. In 38 microseconds, light travels 11 kilometers. Without correction, your position would drift 11 kilometers per day. By noon, wrong city. By next week, wrong country. Dangerous. Engineers built the correction in. Every GPS satellite adjusts its clock. On purpose. Your phone does relativistic physics right now. Every blue dot, every turn-by-turn direction. Einstein's 1907 thought experiment, running in your pocket. The universe keeps strict books. Your phone reads them. A man imagines a falling elevator a century ago. Today, billions navigate using his insight. That's not philosophy, that's engineering, that's proof. But what happens when gravity gets extreme? Let's break time. Imagine a star, 8 times heavier than our sun. It burns for millions of years. Fuel runs out. Core collapses. In seconds, everything becomes neutrons. The entire core compressed into a ball 20 kilometers wide. The distance you drive to work, that's a neutron star. Surface gravity is 200 billion times Earth's gravity. Drop a marshmallow from 1 meter. It hits at 2,000 kilometers per second. Releases energy like a nuclear bomb. Brutal. But gravity isn't the strangest part. Time is. On a neutron star surface, time runs 30% slower than far away. Spend 1 year there. Come back to Earth. 1.4 years have passed here. You aged 12 months. Everyone else aged nearly 17. We can go more extreme. Black holes. At the event horizon, time dilation becomes infinite. Infinite. From your perspective falling in, seconds pass normally. From Earth's perspective, they never see you cross. You freeze, dim, fade into invisibility, hovering at the edge forever. Time near the horizon passes so slowly that signals take forever to escape. Quiet. The universe keeps savage books here. Time doesn't slow, it stops. So far we've learned this. Light clocks prove time dilation is geometry. GPS proves it affects daily technology. Neutron stars prove it scales to extremes. But what does it mean? Not for satellites. For you. For reality. Here's where most explanations stop. Gravity bends time. Satellites need corrections. Done. That's not the point. You've been asking the wrong question. Not why does gravity slow time? What is time? The answer destroys everything. Time is not a river flowing around you. Time is not a background, not a stage. Time is geometry. Wrong. Let me be precise. Time is your geometry. You are not moving through space-time. You are space-time, experiencing itself from one particular curve. Every atom in your body exists at a specific location in space-time. That location has a curvature. That curvature determines how much duration you experience, not how fast clocks tick, how much existence you get. This isn't poetry. This is physics. Your basement self and rooftop self are different temporal beings. Same person. Different time rates. Both real. Here's where your intuition fails completely. There is no universal now. Your now is not my now. Each point in space-time has its own local present, own rate of duration. The universe doesn't have a master clock, beautiful and lonely. No one shares your exact time. Not your mother, not your child, close, but not the same. The universe keeps personal books. One ledger per point in space-time. Your future self is being sculpted by where you stand. Nanoseconds over a lifetime, but real. You always knew where you stand matters. You didn't know it was this literal. Let's return to where we started. Your head aging faster than your feet. Sounds like a trick. Now you know. It's the literal architecture of reality. Space-time is curved. Mass does the curving. Time is the curve. Do this right now. Next time you're in an elevator, going down, know this. You're moving into slower time, deeper into Earth's gravity well. Going up, climbing toward faster time, flatter space-time. Every elevator ride is a time machine. Tiny, imperceptible, but real, simple. Why does gravity make clocks run slow? The answer isn't about clocks. Clocks are just witnesses. Gravity makes time itself run slow because gravity is the shape of time right now. Reading this. Aging at a rate determined by the planet beneath you. You didn't choose this planet, this gravity, this time rate. But here you are. The universe doesn't negotiate. Here's my final question. If time is personal, if duration is local, if your existence rate depends on where you stand, who are you really sharing time with? Astronauts on the space station are aging differently. Right now, someone on a planet orbiting a neutron star might live their entire life in what feels to you like an afternoon. Same universe, different times. Next time someone says, time flies, they're more right than they know. Time does fly, and drag, and stretch. Just not because of how you feel, because of where you are. Look down at your feet. They're younger than your eyes reading this. Always have been, always will be. Welcome to space-time.